So we're now going into chapter 6 and we're going to talk about increasing returns to scale and monopolistic competition. So this is another type of model of trade. There's the Ricardian model, there's Heckscher-Ohlin, there's other kinds as well. And monopolistic competition is a particular model designed to explain certain characteristics of trade. So before we get into the detail of the model, we'll do a quick run over of imperfect competition. Then we'll talk about the trade under monopolistic competition model. And then we'll do two things that are not modeling per se: the phenomenon of intra-industry trade and how you measure it, and the gravity equation model idea. So let's get going. Here's an example of one good which has a two-way flow. The United States both imports and exports golf clubs. So here is data on US imports of golf clubs, and you can see the number one import source is China, then Mexico, then Vietnam, then Japan, Taiwan, Thailand, and so on. So here is the chart showing the destinations of US exports of golf clubs. So the US's number one market to sell to is Japan. And then the US exports golf clubs to Canada, Korea, Australia, Hong Kong, and so on. On the previous slide, Japan was an exporter to the US of golf clubs. So between Japan and the United States, there's a two-way flow of golf clubs. So to explain why the US exports and imports golf clubs, we're going to use a monopolistic competition model instead of a perfect competition model. If you recall your basic intro econ, when we talk about markets, we often will explain that there are four basic types of market. Perfect competition, where there are many buyers and sellers and there's one homogeneous type of good. Monopoly markets, where there is only one producer of a good. Oligopoly markets, where there are a small number of producers, small enough that they have some degree of control over the price of what they're selling, but those producers have to consider the reactions of rivals. In oligopolistic competition, it's not like a monopoly where you can just set the price what you want. Oligopolistic competition means a sort of game theory situation. A small number of powerful or dominating sellers have to think about the reactions of the other members of the group. Monopolistic competition is a situation where the good can be differentiated. The other three types of market, you're talking about trading a single homogeneous identical good. Monopolistic competition allows the good to have different varieties or versions, which means you can have multiple sellers, each of whom has a little degree of market power because the version that they're selling is unique. So if we apply that to golf clubs, you can imagine that there are very high quality golf clubs, very expensive golf clubs, and there are cheaper golf clubs, and so forth. So imperfect competition is the way we're going to try to explain two-way trade in the same type of good. In this chapter, we'll talk about the basics of the monopolistic competition model. We'll talk about how consumer choices and prices are affected under this model when you open up trade between two countries in a two-way flow of the same kind of good. We'll talk about the gains from international trade under the monopolistic competition situation. And we'll talk about two concepts, the index of intra-industry trade and the gravity equation. So most goods are actually differentiated good. They're not perfectly homogeneous. They're not identical. And when we also allow for imperfect competition, that allows firms to influence the price they charge. So monopolistic competition has two key features. One is that the goods produced by the different firms are differentiated. They're not identical, which is what opens the door to having different prices. And also, firms are assumed to enjoy increasing returns to scale. So the average cost of production of a good for a firm decreases as that firm produces more output. So how do we solve for the problem of what should be the monopolist's choice of PM, the price at which it will sell? Well, the sort of fundamental answer is you can figure out what the monopolist will do by thinking about marginal conditions. And what we mean by marginal conditions is this. The monopolist will start out offering to sell the product at a very high price. So that PM will be very close to that top intersection between the red line and the blue line. Now at that point, you can see that marginal revenue is a lot greater than marginal cost. Marginal cost in this example is really simple. It's the extra cost of producing one unit does not change no matter how much production is going on. So that's why the marginal cost line, the horizontal red line, is flat. It doesn't go up, it doesn't go down. So that's nice. That's like saying whether we go from 1 unit to 2 unit or 200 units to 201 units or 1,000 units of production to 1,001 units of production, the extra cost of producing that one extra unit is the same. So that's why the marginal cost line, the MC line, is perfectly straight and parallel to the axis there. So that makes it easy. So MC isn't going to change. We don't have to worry about the firm's level of production causing the price of producing the next unit to increase or decrease. So the logical marginal thinking way to proceed is for the monopolist to start with a high PM and then start to lower the PM, lower the price demanded, as long as marginal revenue is greater than marginal cost. The firm will keep producing more and more units of the good up until the point where the extra cost of producing one more unit wipes out the extra revenue, that is to say the price that the firm receives from producing the one more unit. So MR equals MC is the determining equation for where the monopolist will stop expanding. And so that's why production will occur at A, The market price, which the monopolist can control, remember, is PM, and the quantity sold, which ultimately comes down to the decision of the buyers, is QM. So this is the monopoly model, and it shows how the monopolist can choose to sell at whatever price they want, but they'll sell at the price which maximizes their profit, and the firm maximizes its profit by choosing QM at that point where MR equals MC. You see the dot there. So the blue line is a little bit strange for this duopoly situation, but let's just take it that it represents some kind of total level of production of both varieties of good if the price of both varieties of good were at a certain level, like P1 or P2. So that's not an exact ideal representation, because really you should have two different demand curves for each of the two varieties. But just go with it. So we got the blue line there, and the industry demand curve is determined by the preferences of the buyers. Now let's move to the next curve. Let's look at that sort of pink line in the middle there. What does that represent? Well, imagine as a starting point that both firms are producing the two different varieties of goods at point B. So at point B, you actually have two firms. Each of them are producing their two varieties, and imagine it's 50% each. And so what that means is you're starting at B. Now imagine one of the two firms lowers the price that it is asking for its variety of the good. Then for that one firm, it will now follow the middle pink line down to the right to point C. That's the amount that one of the firms will be able to increase its production and sales by of its own variety if it lowers the price on the variety of the good that it sells. So in a sense, it's almost like there are two of those pink lines coexisting. One is the pink line for firm 1, and the other is the pink line for firm 2, but they have the same, they're actually overlay, they're actually the exact same kind of direction. So if one company decides to lower the price that it's asking for its variety, its production will move from B to C dash. So you've really got two of those pink lines. Okay, two of the pink lines, and each of them is saying what would happen if one of the firms reduced the price it's asking. Now, if you put that kind of behavior together, and now imagine a sort of third situation. The third situation goes like this. Each firm produces the kind of variety of the good that it produces, but the two firms have agreed that they're not going to try to compete with each other, and so they're going to coordinate. And the two firms have each agreed that they'll each charge the same price for their particular product. And so that gives you this sort of purple line now, which tells you what the demand for a variety is if the two firms coordinate to lower their asking price. So that purple line is the D divided by 2, the 50% share that goes to each of the two firms, but only when they're coordinating, and in such a way as to divide the market between them. So the purple line is the line when the two firms cooperate. They don't try to undercut each other. The middle pink line is the line where one firm stays put at B and the other firm decides to try lowering its price. And it moves along the pink line there. So we'll run through the monopolistic competition model. So there are assumptions. Assumption 1, each firm produces a good that is similar to but differentiated from the goods that other firms in the industry produce. And each firm faces a downward sloping demand curve for its product and has some control over the price that it can charge. Assumption 2, there are many firms in the industry. And if the number of firms is N, then total demand D divided by N is the share of demand that each firm faces when the firms are all changing the same price, charging the same price, I should say. When only one firm lowers its price, however, and the other firms don't change, it will face a flatter demand curve. So if one firm lowers its price and the other firms don't do anything, then the first firm has some advantage. It's going to increase its quantity demanded. It's going to increase its sales by more than if it had to strictly stick to the agreement to share equally. Assumption 3 is that firms produce using a technology with increasing returns to scale. So as you increase the level of your output, your average cost goes down. And that can be explained by saying, for example, the firm has a big fixed cost. Even if the firm isn't producing anything at all, it has a very high cost that it has to absorb, a fixed cost. But as the firm increases the level of production, that fixed cost is being spread over more and more units, and so the average cost will fall. And in this diagram, marginal cost is a constant. So as you increase your total production more and more, your average cost is going to approach the level of the marginal cost. So there is competition in this model, but the competition is not from the firm producing a different variety from you. The competition comes from the potential for another firm to enter the industry and produce what you are doing. So in the short run, a firm producing a differentiated product faces this diagram. The firm will produce up to the point where marginal revenue equals marginal cost. That's always a fundamental principle of any of these kind of industry models. Look for the point where marginal revenue equals marginal cost. And that is where the firm will choose to go and choose to stay at that level of output. Now, if there was no free entry or exit, you would stay in this situation forever. However, there is free entry and exit. Let's suppose that there is no international trade. So you have the market for this good, and you have a firm producing one kind of variety, and initially it has the market to itself internally inside the country. This is the long run monopolistic competition equilibrium without trade. In the long run equilibrium, firms do not earn monopoly profit because the entry and exit of firms in and out of the industry will ultimately eliminate any excess profit. So firms will end up at a point like A, where their revenue is exactly balanced out by their costs. So average cost times quantity is equal to price times quantity. So there's zero net profit. And what pushes the original domestic firm to this difficult position is the entry of competitors who are kind of taking chunks of the market away from the original firm. So, for example, one country can specialize in being the dominant producer and exporter of high-end golf clubs, and another country can specialize and take advantage of economies of scale in producing a different type of golf club. So you can have production of golf clubs in different countries, but they're not exactly the same type. One country specializes in doing the high end, another country specializes in producing the middle end, let's say. So this is very consistent with the basic idea of a monopolistic competition market. We talk about the perfectly competitive market, we talk about monopoly, we talk about duopoly or oligopoly, and the fourth kind of market, forgetting about international trade, the fourth kind of market is called monopolistic competition. And monopolistic competition is where you have many producers of a good, but they are differentiated versions of a good. So, for example, running shoes. You have many companies that produce running shoes. How come there isn't just one company, let's say Nike, that produces all of the running shoes? Well, what actually has happened is different companies have specialized in producing particular variations, particular types of running shoe. So that's why you can have an equilibrium. They're each dominant in producing a particular kind of running shoe. So if we open the market to international firms, those firms just push the tendency to have more and more varieties of the basic good, more and more producers of all the different basic goods. You just push in the same direction, but even further, because now you have entry and exit of firms, not just within the same country, but entry and exit of firms into a particular kind of production of a particular kind of product happening all over the world. So what's the benefit to the consumer from all of this? Well, the benefit to the consumer of products produced globally is a drop in price because of the specialization in producing particular types of variations of products, taking advantage of increasing returns to scale. It's now possible for products to be bought at a lower price. So the specialization creates the efficiencies that allow prices to be lower. And there's also an increase in variety. It's not just the same goods are cheaper, there are many different varieties of each good possible because they're being produced in many parts of the world. So think, for example, of coffee. You can buy coffee beans from around the world at your local coffee shop, and each type of coffee from each country, from each producer, is carefully branded. You don't have a big market of a sort of a generic bag of ground coffee. What you have is, it's important for each producer to differentiate, at least in the mind of the consumer, their kind of coffee. So in some sense, it's the ability to separately brand your product, signal that it is somehow unique, that allows many countries to get into the business of exporting coffee to consumers around the world. And you have more variety, and because of all the competition, there's a drop in price. Imagine if you had to buy all your coffee from the United States. It wouldn't be very good. There is an index called the Index of Intra-Industry Trade. And the Index of Intra-Industry Trade is an indicator of how unbalanced a country's trade is for a particular sort of good. So if the index is very high, it indicates that an equal amount of the good is being imported and exported. So a value of 1 here means your imports and exports of the good are equal. At the other extreme, a low index value of 0 means that your country only exports or only imports the good, but it doesn't export and import at the same time. So there's the index there. Index of intra-industry trade is equal to the minimum of imports and exports divided by half times imports plus exports. So to give a sense of the intuition, let's assume we're talking about US imports and exports of coffee, and we'll work in millions of pounds of coffee. So let's suppose the imports of coffee into the US 1 year equaled 100 million pounds. And let's suppose the exports of coffee from the US equaled 10 million pounds. So the numerator is 100 million plus 10 million. So the total value for the numerator is 110 million. Now the denominator is 1/2 of imports plus exports. So that's 1/2 of 100 million plus 10 million, which is 110 million, times 1/2. 1/2 of 110 million is 55 million. So what we have in the numerator is the minimum of imports and exports, and the minimum happened to be exports, 10 million. So the number in the numerator is 10. And the denominator is the average of 110 million, so that's 55. So top value is 10, numerator is 10, denominator is 55, so 10 over 55 is approximately 1/5 or 20% or 1/5. Not exactly, of course, but 1/5, let's just say approximately. So that indicates US trade in coffee is very unbalanced. The US imports a lot more coffee than it exports. Now, let's take the other extreme. The other extreme would be, what if the country had really balanced imports and exports? So let's suppose the US imports 100 million bags of wheat, okay? And it exports 100 bags of wheat. So import 100 million, export 100 million. So 100 plus 100 is 200, measured in millions of units of wheat. Okay, so numerator 200 million. 100 million for imports, 100 million for exports. Go down to the bottom, the imports and exports are 100 plus 100, and half of that, half of the 200 is 100. So what do you have in the numerator? 100. In fact, in this case, you can pick either the imports or the exports. It's not, neither of them is the lowest, so it doesn't matter which one you pick. So 100 in the numerator, 100 in the denominator, 100 over 100 equals 1. So in this case, the index of intra-industry trade equals 1, which indicates completely balanced trade. So we use this index for specific types of products or specific sort of from specific industries as a rough estimate of how unbalanced the trade is between the US or country A and country B within a particular industry. Here's another concept called the gravity equation. It turns out that even after you allow for factors of production and technology and variations in types of products and all those sort of logical things, when you come to explain trade between countries, distance between countries makes a difference. Now, distance makes a difference even after you compensate for the cost of transport. Let's be clear here. The gravity equation idea takes care of transport costs. So that's not the explanation for why countries that are close to each other trade more than you would expect. That's what the gravity equation idea is about. It's sort of an analogy, right, to physics, where two bodies closer to each other have a stronger gravitational pull. And in economics, it turns out trade is that way. So if you take, let's say, trade between one United States state and, let's say, some province in Canada, the closer is the US state and the Canadian province, the greater is the flow of trade, even after you allow for transport and every other thing you can think of. After you've eliminated everything else, countries or states or units of government that are close to each other trade way more with each other than you would expect after allowing for every other kind of thing you can put in there. And so that's why this gravity effect is kind of interesting and true, but it's kind of frustrating for trade economists because all we've got is physical distance and we cannot sort of totally kind of know why that matters so much. Now there is speculation that stuff like proximity of people has something to do with it. So it could be proximity of one country to another country. Maybe there's more similarities in how people do business, or maybe, I don't know, how they taste in products. We don't quite know. But that's the idea of gravity. After allowing for every other economic factor, pure physical distance has some kind of powerful positive force that reinforces trade. Now, if you want to make this practical, what it suggests is that trade between the United States and Canada and trade between the United States and Mexico should be especially high, simply because these countries are close to the US. So if you want to work with developing trade, and you want to work with gravity instead of against gravity, try to promote trade with a country that's close to you. That's sort of a practical application. So here you see the analogy between physics and this gravity theory or gravity equation for trade flows. The top level is the Newton's universal law of gravitation, and you have the force of the attraction equals G, which is a constant, times mass of the first thing times mass of the second thing divided by distance squared. Well, it turns out in trade, the flow of trade between two countries can be predicted by a coefficient B times the GDP of one country multiplied by the GDP of a second country divided by distance raised to some power, which could be the power of 2 or some other power. Now, the GDP numbers are not the literal numbers measured in trillions. They're based on some kind of index. So if you take the GDP of the US and set that at 100 as a benchmark, then GDP2 will be a sort of proportional adjustment up or down, depending on how much the GDP of the second country compares to the US. And it turns out that that really simple equation does a surprisingly good job of predicting trade between different countries. So how does this gravity equation model work? If you actually look at data, well, one study was study of trade between US states and Canadian provinces. And that's a good way to test the gravity idea, because when you're talking about trade between the US and Canada, you don't have so many complicating factors like trade tariffs and other impediments to trade. It's a fairly free flow. And so what you find is when you use the gravity equation, the closer a US state is to a Canadian province, the more trade it has. The bigger are the two province and states in economic size, the more powerful is that connection also. So there does seem to be something to do with proximity that facilitates trade. And if you do a comparison between Canadian provinces, perhaps you really are worried about sort of trade rules between the US and Canada. Okay, look within the same country, Canada, trade between provinces. GDP, proximity, physically, predicts pretty well how much trade there will be between the different Canadian provinces. So let's just run quickly through some of the conclusions. The monopolistic competition model is an explanation for why countries trade with each other, even if we don't think that technology is a factor, and we don't think that factor resources differences are a factor. You still can have reasons to trade and explanations for trade by allowing to have different varieties of the same good. So instead of talking about there's a generic corn and a country either exports corn or it imports corn, you can say there are different varieties of corn, different types of corn. And so what that does is it opens up the possibility that the production of corn globally can be occurring in many countries. And it makes sense because countries specialize in producing particular kinds of corn. So there's this variety, differentiated products, fact. And so that means that even if countries are really identical, they can still specialize in different varieties or variations of the same product. and trade with each other. And there's other factors like the size of markets and so on. So we get lower prices and higher variety of products under this monopolistic competition scenario. However, for this to work, you must have free entry and exit into the market by firms. So that's what allows this process of specialization and differentiation to occur. And we also have this gravity equation idea, and that actually can be connected to the monopolistic competition model, but we're not really kind of into looking at that angle. And the simple idea of the gravity equation model is that everything else equal. If two countries have bigger economies, they'll trade with each other. If two countries are physically close to each other, they will trade more, everything else equal.